In this video, we're going to talk about the accessories that we have available for our Bridgeport here at the MakerBarn. Get everybody familiar with what we have in stock. Some of this is stored away in different cabinets, that sort of thing, so you may have to look for it. Anyway, probably the most important accessory to a milling machine is the milling machine vise. We have this Kirk analog vise is a 688, which means it's 6 inches wide, has 8.8 inches of jaw travel. The vise is set up to be precisely square with the table, and we'll cover that in a later video, how to go about doing that. But you can see it's very substantial. The vise weighs about 70 pounds, so if you take this off the table or put it back on, please be careful, because if you drop this on your foot, it would, even with steel-toed shoes, it would not be good. The jaws are movable and replaceable. Right now we've got some soft jaws in there, and you can see some little ridges have been cut in here, and that was for a particular task we were doing. But I'll go ahead and show you what the other jaws look like. To replace the jaws, I'm going to open the vise and use a 3/8 inch hex wrench. We can unbolt the current jaws that are in there. The wide jaws, and I just set them in there so you can kind of see. But you can imagine with wider jaws like this, you can hold wide pieces very stable, in a very stable manner. And if you come back and machine these steps right here, this rabbet, if you're a woodworker, and machine it in place, maybe put a couple of what we call 1, 2, 3 blocks in there to stabilize things. It'll make it very, very precise in the Z-axis as well. This plane will be perfect with the milling machine itself. So that's another set of jaws. And let me show you this. These jaws could be mounted here, and they could also be mounted out here, which gives you an extreme amount of clamping capability. And the last set of jaws that we have handy, these are the actual jaws that come with the vise. They're hard, they're hardened steel, and they're precision ground. And I'm just going to set it in place. And they have a neat thing. The back jaw has a little device. It's located right here in the front of the vise. And this little gizmo here, you can slide in a stop. So you can move this stop around. And we store it here in front of the vise. Now, we don't generally keep these jaws on, mainly because they're rather expensive, and we're in a learning environment here. It's not unusual for a jaw to get hit with a cutter, so especially when you're in the learning environment. So we just kind of keep these jaws in the toolbox, and if you need them, you're welcome to use them, but please be careful with them. They're very precise. If you're going to do some very precise work, then this might be a good choice for the jaws that you use. One important accessory on a milling machine, it's not strictly necessary, but most anybody operating a milling machine today uses them, is a digital readout system. Now this is a Sony Millman. It's a model LH30. You can probably find a manual on the web for this. It's it's capable of determining the X and Y coordinates of our table. I'm moving a cross feed right now. There's longitudinal feed. You can zero it out at a particular point and work from there. There's various features it has. Honestly, it's a little strange compared to most digital readouts, but it works quite well. And the spars are located underneath. There's a spar for the spar or scale. They have different names for them. But there's one underneath here for the y-axis, and then this big long one is in the back here. This is for the x-axis. All right, and so this takes care of our x and y, and we also have a readout for the z. It's separate. All right, this is the z-axis readout. This little Mitatoya thing. It's mounted on, essentially on the quill. It's measuring the movement of the quill. I move this up and down, you can see the readout changes. So I could zero it out. And typically I'd come down and say maybe touch the top of a piece, touch the top of the workpiece with a tool and zero it out, and then work from there. There we go. So it's handy too. So we have full digital readouts on X, Y, and Z. X, Y, we have a resolution of 0.2 of a thousandth, and this one has a resolution of, I believe it's a 0.5 thousandth. Both systems can be converted, can be switched between inch and metric. So if you have to work metric, no problem. We can switch that easily, even though this is an inch-based machine. All right, this is really a handy accessory. This is a rotary table. I believe this is a 6-inch rotary table. Even though it's a 6-inch rotary table, it's still quite heavy. It's probably in the range of 40 to 50 pounds. But as you can see, I can crank this, and I don't recall what the ratio was. I think it's about 60 to 1 on the ratio here. In other words, 1 degree, one rotation would be 1 degree, I believe. But we can look that up, make sure. Anyway, this table you can mount things to, and you can make circular cuts, that sort of thing. You can also use this one in the vertical position, like this, and just simply clamp it down with the step clamps. And we don't have a tail stock for it, but those are available, or you could build one. So you could actually work between centers on the milling machine. It's a nice accessory, and it's especially handy for model makers that need to make complex shapes on the manual machine. Well, sometimes you have to clamp round objects. So this is simply a lathe chuck that's been mounted on a nice flat plate and steel plate. And all you have to do is clamp this down a couple places, 2 or 3 places, with step clamps, and you can hold round parts to do complex machining on the round parts. This might be an example of a part that may need to be drilled or machined on the inside. And something you could do in a lathe, you have to do here. Anyway, this is a neat little thing, and it's easy to use. It's 15, 20 pounds. It's usually said that the milling machine is for making straight cuts, and so we'll find lots of these different devices that allow us to make curves and circular cuts, that sort of thing. And this is one. This is an indexing machine, indexing head. It's got a lathe chuck on it, but the chuck is, you could take the chuck off and put another type of chuck on there if you want to. This is an interesting device. This will work horizontal or vertical. It's quite heavy, actually. It's got a nice buck chuck on it. There's a dial down here. You can see that it reads out in degrees, and this actually, see, you work the lever. Oh, if I can, oh, there we are. It was locked. And you can actually lock it in 1 degree increments. Bring it over here, lock it down, make your cut. Unlike the rotary table, you can't move this thing while you're making a cut. Rotary table, you can crank it while you're making a cut. This is just for positioning. And it's kind of a neat thing to play with. They're a little outmoded with DROs on our machines. Quite often if we're trying to do a complex bolt pattern, we would just convert it from rectangular coordinates and use the DRO. But it's kind of a slick thing, still and all. Nice. Wow, yet another device for doing circular things. So this is a rather special device, and you may have heard about these. This is a dividing head. I'm a little more familiar with the Brown and Sharp type dividing heads, which actually have this dividing dial on the other side, so it's a little different. But first off, this head can be rotated, It's on 0 right now, but these bolts can be loosened up and instead can rotate to a vertical position. And this is a standard 40 turns, 40 cranks per revolution here. And what this plate does for you is this is for setting up precision dividing. These are what are called sector arms, and the sector arms allow you to set a start and a stop point, and so you can make fractional. So what the whole idea of the dividing head is you can divide a circle very precisely. And then also you can do 2 types of division. One is a direct, we're using this pin and reading off right here, and I don't know how many, generally I have 24, it may be more than that on this one, positions that you can put it in. Or you can do the indirect dividing by using a gear mechanism. Always turn one direction though, because there's always going to be a little bit of backlash. So always make sure when you're doing something like cutting a gear teeth, for instance, that you work in one direction. Anyway, that's a really nice tool to have. We've got other plates for it. These plates have different numbers of holes. So if you're interested in doing a little math, you can figure this all out, or you can just go to the machinery handbook and look up if you need 128 divisions, where you can set this to make 128 divisions on your piece, 128 gear teeth or 64 gear teeth. There are some limitations. For instance, I couldn't do 127 on this. It's a large prime number, and it's unfortunately I'm not capable of doing large prime numbers. But there's another trick to do that. Anyway, let's not get into that right now. But anyway, this is a nice thing to have, and it's in our storage cabinet. So now this is one of those attachments that falls into the, gosh, when would I ever use that thing? And boy, I sure hope I never have to use this thing. But it basically converts the vertical mill, the Bridgeport vertical mill, into a horizontal mill. Now, there are actually supports that are available to go out here on the dovetail of the ram, and you could run an arbor just like as if it was a horizontal milling machine. But for the most part, this is used in cases where you have to put holes in the end of a long piece. And something that most machinists really don't want to have to do, but sometimes it's necessary. And sometimes the piece is too long. Sometimes you can put it on the side of the table and move the turret and all to get at, but sometimes those pieces are 6 or 8 feet long, and you've got to put holes and thread them in the end of and this is the only way to do it. Just use the indicator. You can get this thing square with the ways of the mill, and you can put chucks in there and milling bits. You could do a milling on the side of something that you couldn't get otherwise. Kind of, to be honest, it's sort of a last resort tool, but it's one of those things that if you need it, you're really glad you have it. Anyway, that's it for the accessories that we have, these special accessories, and we'll get into actual operation of all these things later on, and maybe we can even cut some gears later on. That's kind of fun. Anyway, hope you enjoyed watching this, and don't forget to make chips. Thanks.